Now, persistence is something that I think Netflix got right early on. There isn't a war story here about how we got it wrong. And let me tell you how we got it right. We got it right by starting off thinking about the right constructs and about CAP theorem. I assume how many people are not familiar with CAP theorem? I'm just sort of curious. OK, so we've got a few. Let's go ahead and level set here. This is the simplest definition that allowed me to get my brain around what this really was. In the presence of a network partition, you must choose between consistency and availability. In this case here, you might have a service running in network A, and it wants to write to databases a copy of the same data into databases that are running in 3 different networks. Or in AWS, this might be 3 different availability zones. The fundamental question is, what do you do when you can't get to one or more of them? Do you just fail and give back an error, or do you write to the ones you can get to and then fix it up afterwards? Netflix chose the latter and embraced this concept of eventual consistency, where we don't expect every single write to be read back immediately from any one of the sources that we've written the data to. And Cassandra does this really well, and it has lots of flexibility. So the client might write to only one node, which then orchestrates and writes to multiple nodes. And there's a concept of local quorum, where you can say, I need this many nodes to respond back and say that they've actually committed the change before I'm going to assume that it's written out. And that could be one node if you really want to take on some risk in terms of the durability, but you're willing to get very high availability. Or you can dial it up the other way and say, I want it to be all the nodes that I want to write to. So let's move on. I'm just going to briefly talk about infrastructure, because this is a whole topic unto itself. But at some point, your infrastructure, whether it's AWS or Google or things that you've built yourself, is going to fail. The point here is not that Amazon can't keep their services up. They're actually very, very good at it, but that everything fails. And the mistake, if I were going to put blame on anybody in terms of what happened in Christmas Eve of 2012, when the ELB control plane went down, was that we put all our eggs in one basket. We put them all in US East 1. And so when there was a failure there, and by the way, we've induced enough of our own to know that this is also true, there was no place to go. And so Netflix developed a multi-region strategy with 3 AWS regions, such that if any one of them failed completely, we can still push all the traffic over to the other surviving regions. So I did a talk on this earlier in the year. So I would encourage you to take a look at it if you want to get really deep into the multi-region strategy and all the reasons that it evolved the way that it did. But at this point, I'm going to put a pin in this. I'm going to move forward. So let's talk about scale now. And with scale, I'm going to give you 3 cases: the stateless service scenario, the stateful service scenario, these sort of fundamental components, and then the hybrid, similar to the diagram that we were looking at earlier, where it's an orchestrated set of things that come together. OK, another question. What's a stateless service? Anybody have an idea? Want to throw out their idea, their definition of it? Ah, brave soul, good.
Nothing really persistent in the sense that there's no information that can change from request to request.
OK, that's close. That's interesting. I start with, it's not a cache or a database. You're not storing massive amounts of data. You will frequently have frequently accessed metadata cached in memory. So there's the non-volatile nature of that, or configuration information. Typically, you won't have instance affinity, where you expect a customer to stick to a particular instance repeatedly. And the most important thing is that the loss of a node is essentially a non-event. It's not something that we should spend a lot of time worrying about. And it recovers very quickly. So you should be able to boot up and spin up a new one to replace a bad node relatively easily. And the best strategy here is one going back to biology, is one of replication. Just as with mitosis, we can create cells on demand. Our cells are constantly dying and constantly being replenished. Autoscaling accomplishes this. I'm sure most people are familiar with autoscaling, but I can't underscore enough how fundamental this is and how much this is table stakes for running microservices in a cloud. You've got your min and your max. You've got a metric you're using to determine whether you need to scale up your group. And then when you need to have a new instance spun up, you simply pull a new image out of S3 and you spin it back up. The advantages are several. You get compute efficiency because you're typically using on-demand capacity. Your nodes get replaced easily. And most importantly, actually, is when you get traffic spikes, if you get a DDoS attack, if you introduce a performance bug, autoscaling allows you to absorb that change while you're figuring out what actually happened. So this has saved us many, many times. Strongly recommend it. And then, of course, you want to make sure it always works by applying chaos. Chaos Monkey was our very first sort of chaos tool. And it simply confirms that when a node dies, everything still continues to work. This has been such a non-issue for Netflix since we've implemented Chaos Monkey. I kind of want to knock wood as I say that. This just doesn't take our service down anymore. Losing an individual node is very much the non-event that we want it to be. So let's jump in. Let's talk about stateful services, and they are the opposite, obviously, of a stateless one. It is databases and caches. It is sometimes a custom app, and we did this, a custom app that has internalized caches, but of like large amounts of data. And we had a service tier that did this, and as soon as we went multi-region and tried to come up with generic strategies for replicating data, this was the biggest problem we had. So I strongly recommend you try and avoid storing your business logic and your state all within one application, if you can avoid it. Now, in this case, what's meaningful is, again, the opposite of stateless, which is that the loss of a node is a notable event. It may take hours to replace that node and spin up a new one. So it is something that you need to be much more careful about. So I'm going to talk about, and I'm going to sort of tipping my hand here, two different approaches for how we dealt with caching to sort of underscore this. And again, as I said, we had a number of people who were from Yahoo who had experience using HA proxy and squid caches, and a pattern where they had dedicated nodes for customers. So a given customer would always hit the same node for the cache, and there was only one copy of that data. The challenge is, of course, when that node goes down, you've got a single point of failure, and those customers would be unable to access that service. But even worse, because this was in the early days, we didn't have proper Hystrix settings in place. We didn't have the bulkheading and the separation and isolation of thread pools. And so I can still remember being on a call where one node went down, and all of Netflix went down along with it. It took us 3.5 hours to bring it back up, to wait for that cache to refill itself before we could fulfill requests. So that's the anti-pattern, the single point of failure pattern. And going back to biology, redundancy is fundamental. We have 2 kidneys so that if one fails, we still have another one. We have 2 lungs. Same thing. Now, it does give us increased capacity, but we can live with only one of them. And just as your human body does that, Netflix has approached an architecture using a technology called EV cache. And EV cache is essentially a wrapper around memcached. It is sharded, similar to the squid caches, but multiple copies are written out to multiple nodes. So every time a write happens, not only does it write it out to multiple nodes, but it writes them into different availability zones. So it sprays them across and separates them across the network partitions. And likewise, when we do reads are local because you want that local efficiency, but the application can fall back to reading across availability zones if it needs to get to those other nodes. This is a success pattern that has been repeated throughout. EV cache is used by virtually every service that needs a cache today at Netflix, and it's been highly useful to us in lots of good ways. Now let's talk about the combination of the two. This is the scenario we talked about earlier where you've got a hybrid service.